Okay, today we are going to talk about lesson 35 and we're going to move on to solving quadratic functions. So the first question I have for you, and I want you to answer this, what is standard form of a quadratic function? Okay, so next we're going to talk about what does it mean to be a zero of a quadratic? Well, that means that we set it equal to 0, meaning that our y value would be 0. So it's any time our y value is 0 for our quadratic equation. If we think about that graphically, that means we have an x-intercept. So graphically, we're talking about x-intercept. So anytime you see that 0, if it asks for a 0, you know you're going to find an x-intercept. We're going to briefly talk about the zero product property that's going to help us with solving these quadratic functions. If you have two pieces multiplied together and they equal 0, that means either A or B has to be 0. They could both be 0, but at least one or the other needs to be 0. So you're going to be given a problem. We're going to ask you to find the zeros. Here is our function, 9x squared minus 16. We have to set that equal to 0. We need to know when is that function value 0. So our first step, set it equal to 0. Well, now we need to factor that to help us solve. It factors to be 3x plus 4 and 3x minus 4. This is where that product property rule comes into play. Either one of these pieces has to be 0, so we set each of them equal to 0 and solve for our x. So I did that here. If you subtract 4, divide by 3, you get negative 4/3. On the right side, if you add 4 and divide by 3, you get a positive 4/3. These are your two zeros for this function. In other words, graphically, this is where your graph would cross the x-axis. Okay, let's do another one that won't factor quite like this. Here is a of x. We have 2x squared plus x. We can't factor it into two pieces, but we can take an x out. Do set it equal to 0 first before you factor. Take out that x. Still, the product property rule applies here. So you're still going to set each piece equal to 0. You have x equals 0, and then x equals negative half. We've talked a little bit about this before, but anytime you see the word root, that is the exact same thing as finding a 0 or finding a solution or finding an x-intercept. So knowing that all 4 of those words mean the same thing can help you when you're solving a problem. So now I want you to find the roots of this quadratic equation. Okay, a couple general things we want to talk about. When you have a quadratic function and we're looking at the zeros, there's 3 scenarios. You can have 0, 1, or 2 roots. We've mentioned this before. If you have no roots, that means that you have a graph that never crosses the x-axis. So no roots doesn't ever touch the x-axis. It could also be up here. Okay, it could be in one of the top quadrants facing up. One root means that you're going to cross the x-axis one time. Since it's quadratic, we call that one root a double root. Okay, so if it touches the x-axis one time, that's a double root. And then you could have 2 roots as well, where you would have 2 x-intercepts, or it crosses your x-axis twice. Okay. Here is an example of what it would look like to have a double root. You have your quadratic function in standard form. We need to solve, so we set it equal to 0. And then we factor to x minus 3, x minus 3. Since both of these pieces are the exact same, that's what makes it the only root. You could set each of them equal to 0, but they would output the same number. So x equals 3 is that double root. Last example here, we're going to kind of reverse the steps. We're going to take two zeros or two roots, and we're going to write a quadratic function from that. So notice back here in this example, our parentheses said x minus 3, and our root was a positive 3. Remember, your sign will always be opposite. So coming down here, we are going to take x and put a minus 1, since that's the opposite sign of our root. And then x plus 5/3. And again, that's set equal to 0. We never have pieces that are fractions, though. So if you remember from our factoring chapter, we can always bring that denominator out in front. So now we have x minus 1 and a 3x plus 5. Now we want to actually write it as a quadratic function in standard form. So we want to FOIL, and then we can combine our middle two terms. You should get a 3x squared plus 2x minus 5 equals your function.